let's form an arithmetic series out of this. If we were to put the number 5 into here, we're going to see that 8 minus 5 is going to be 3, and 5 minus 2 is also going to be 3. So because there's a common difference of 3, this is an arithmetic series. I just chose this number 5 seemingly at random. Where does this number 5 come from? The number 5 is said to be the mean of the numbers 8 and 2, meaning 5 is equal to 8 plus 2 over 2. This is what we call the arithmetic mean, because it's the average of these numbers which are in arithmetic progression. This is undoubtedly the mean which you are used to. What if instead of 5 we put 4 here? Because 8 divided by 4 is going to be 2, and 4 divided by 2 is also going to be 2. There is a common ratio happening here. In fact, these three terms form a geometric progression. And where does this 4 come from? It's going to be 8 times 2, and we're going to square root the whole thing. This is the other type of mean that we're talking about. This is what we call the geometric mean. Let two numbers x and y be non-negative numbers, that means 0 and above. We have this inequality happening here. The arithmetic mean is greater than or equal to the geometric mean. So the arithmetic mean is greater than or equal to the geometric mean. This is a really important inequality in all of mathematics. It's called the arithmetic geometric mean inequality. We can prove this in several ways. One of it is we're going to do proof by contradiction when we visit that much later on. But right now we can do it in a much simpler way. How will we prove this inequality in a much simpler way? Well, we know that if we expand a bracket with two things in there, if these two things are themselves non-negative, this has got to always be a positive thing. So let's expand the bracket. Because x and y are non-negative numbers, we can bring these two xy to the right hand side without worrying about the sign, the direction of the inequality. Close, but not quite. Now let's try, instead of a plus, is now a minus. Whatever x and y are, when we subtract them, it may be a negative thing, but because we're always going to square it, it's always going to be positive anyway. Closer actually. Because x and y are non-negative numbers, we can take the square roots and we're not going to have any complex numbers. And once again, depending on who is the bigger number, it could be positive or negative, but because we're going to square it anyway, it's going to be positive. And there you have it. Given the arithmetic mean of 1 upon a plus b and 1 upon b plus c is 1 upon a plus c, find in terms of b the arithmetic mean of a squared and c squared. Once again, given that the arithmetic mean of 1 upon a plus b and 1 upon b plus c is 1 upon a plus c, find in terms of b the arithmetic mean of a squared and c squared. We know the arithmetic mean of these two guys has got to be 1 upon a plus c. So 1 upon simplifying all of this, we get I brought this 2 over to the right hand side. Simplifying this even further, going to the other side. I simply cross multiply it. Cancelling everything off. Where this 2AB and this 2AB cancels off. Where this 2BC and this 2BC cancel off. Where this 2AC and this 2AC cancels off. We see that square plus C squared equals to 2B squared, meaning A squared plus C squared over 2 is equal to B squared.